All right, in this video, we're going to talk about different type of operations that we have in Python. There are 5 different operations that we can apply to different operands or have them in different expressions or combine them. So the first 2, we already worked with them. We already know what they are and what the result of each one of them is going to be. The first one is called arithmetic operators. And we have exponentiation, multiply, division, truncating division, modulo, plus, and minus. We also had negation. I did not include the negation because it looks like subtraction, but we do have that as one of the operators. And then the other one that we have used so far is assignment operator. With the assignment operator that we use equal sign, we assigned a value into a variable, for instance. And we use assignment operator to do those type of assignments for us. So those are the 2 types that we have worked with. We use them so far. There are 3 new ones that we are going to talk about in this video. The first one in those 3, is the relational or comparison operator. We saw an example of that when I introduced Boolean operators to you, Boolean variables to you or data types to you. And the relational operator basically looks at the relationship between the 2 values that you have and compares them for you. So you can see if value is smaller than another value or greater than another value, if they are equal to each other or not equal each other. It looks at all of those type of relationships. There are different operators that you can apply to different operands that you have. So example of that is less than, greater than, less or equal, greater or equal, not equal, and then equal. So it gives you basically all type of comparison that you want between 2 different values. Let's see an example of those. So similar to what we had in the other video when we introduced Boolean data type. So if you want to see if 5 is greater than 2, you can use this operator, greater than sign, to look at the relationship. Is 5 greater than 2? Yes, it is. So you're going to get a Boolean value as a result. So the comparison operator or relational operator always gives you a Boolean type. Always. It looks at the relationship between 2 values and it gives you either true or false. If you want to see if 2 is equal to 2, then you can look at this relationship. To look for equality of the 2 numbers, we use 2 equal signs. We want to distinguish between assignment and comparison operator. So for assignment, we use 1 equal sign. For comparison, we use 2. So it's very important to keep that in mind because if you just use 1, it's going to give you an syntax error. So is 2 equal to 2? That is true. Is 2 equal to 4? That is obviously is not correct, so it's going to give you a Boolean value false. So you can use different type of operators, comparison operators, to look at the relationship between the 2 values that you have. So you want to see, for instance, if 4 is greater or equal to 4. In this expression, we know 4 is equal to 4, and in that operator, we are covering that equality. So is 4 greater or equal to 4? Yes, it is. So it's going to give you true. If I just say is 4 greater than 4, it's going to be false because it is not. They are equal each other. They are not equal. They are equal each other, and 4 is not greater than 4. So that gives you false. So you can practice with different operators that we have and just play with them, get comfortable with all of those operators. But just keep in mind, that's very important. Comparison operator, relational operators always, always, always give you a Boolean value. There is no exception. They always give you Boolean result. Okay, let's look at the next one. The next one is a membership operator. When it comes with the name, you're looking for membership. You want to see if something is a member of something else. So for that, you need to look at things that have more than 1 item in them. That means sequences. So far we know sequences that have multiple items in them, and you can use membership operators to see and to check to see if something is part of that sequence. So let's see an example of a sequence. and the membership operator. I'm going to make it smaller so my text is not totally at the bottom. Okay, so let's say I have a list of items. I'm going to put a bunch of values here, just random values. And I want to see if this value 2 is part of this list or part of the sequence. I can use a membership operator. There are only 2 membership operators. We have in, or not in. You want to see if something is part of something else or it is not part of something else. So I can say is 2 in this list. And you see in turns orange because it's a keyword. So if I put that here, it's going to give me true because 2 is part of this sequence. I want to see if 10 is in this list, is in this sequence. It's going to give me false because 10 is not part of that. So you can look at different membership operators. I want to see if 10 is not in this list. It is not, so it should give me true because that is a true statement. 10 is not part of that list. It's kind of negating the result of this one. So go ahead and play with it. Try different type of sequences. So for instance, you can have a string. I'm going to say hello world. And you can see if, for instance, you can check just one letter at a time. I can check to see if L is part of S, and it is. Or you can check one chunk of that string and to see if that is part of the bigger string that you have. So you can do one piece of it or a bigger piece, just one item or bunch of items together. So those are the things that you can do. It could be a tuple, so you can have it. It could be any of those sequences that it could be list, string, or tuple. And then later on, we are going to learn about other data types that also allow you to use membership operators on them. Okay. One thing that if you notice is similar to relational operator, the result of a membership operator is always a Boolean value. You want to see if something is part of something else, and the result is either true or false. If it's part of that or it's not part of it. So only 2 values, 2 possibilities. So just keep in mind the result of membership operators are always Boolean values as well. And then last one is a Boolean operators or Boolean or logical that we call them. And we have 3 operators for that. We have not, and or. So with not, let's start with not, which is very simple. Not basically negates whatever you have. So if you have a value that is true, it's going to negate that and make it false. So if I say not true, it's going to give me false. If I negate false, it's going to give me true. So it negates the result of whatever you have. So not, and then here, let's say you want to do, you can combine it with other operators. So if I say not 5 greater than 2. 5 greater than 2 give us true. Not true is going to give me false. So it basically goes through, evaluates all of the expressions that you have and gives you the result. It starts with the relational operator. There's a certain order when you have mix-up operators in your expression, and the details about all of that is in the PowerPoint slides that we have. But it looks at different order of the operators and see which one has proceeding to the other ones, and it starts with that. And examples of that is in like any of the math expressions that you have. If you have 2 multiplied by 5 divided or plus 1, the order of operation is a very simple expression. We all know that 2 multiplied by 5 goes first, and then you add 1 to it. You never do 5 plus 1 first and multiply it by 2 unless you put the parentheses around them. If you parentheses around them, you're changing the order of operations. But if you don't have the parentheses, then it goes from the ones that has a higher proceeding, and multiply has a higher proceeding than plus. So that one goes first. So 2 multiplied by 5 is 10 plus 1 is going to give you 11. And you can apply and combine different type of operators to each other to get the result that you want. Okay, so that was the first one, which is not as a Boolean operator. Again, with Boolean operators, similar to the previous two, you're always going to get a Boolean result as you apply that operation. And then we have and or. With and or, the example that I always have in my class is I talk about different colors, okay? I don't have all of the colors I wanted here, but let's say I have a color that is red and a color that is blue. If I ask you a question that if I have a color pen that is red or a color pen that is blue, I want you to say true, or I want you to do something. I want you to write on a piece of paper, okay? If you have red or blue, you can write. Can you write or not? So you have both red and blue, thus you can write. If I tell you, if you have, let me change this one. If you have a color pen that is red or a color pen that is blue, then you can write. So you still have one red. So that means you can write because you have at least one of them that is true. So you can do that. If I tell you if you have a color pen that is blue or a color pen that is green, you can write. Then you can do it because you have at least one of them that is correct. But if I have a statement like, if you have a pen that is blue or you have a pen that is black, then you can write. You have neither of those, then you cannot write. Okay? So it's with or, it looks at like a general thing. It looks at, it includes most of the stuff. So if you have at least one statement that is true, the entire thing becomes true. So for instance, if I have true, capital T, true or true is going to give me true because at least one of them, in this case, both are true. If I have true or false, at least one is true, it's going to give me true. If I have false or true, it's going to give me true because at least one is true. The only time that it gives me false is if both of the statements are false. Example of that is, let's say I have 5 greater than 2, or 4 is greater or equal to 4, all right? So, or actually, let's do 4 greater than 4. So, is 5 greater than 2? It's going to be evaluated to true. 4 greater than 4 is going to be evaluated to false. So, you have true on one side of it, false on the other side of it, and it's or. So if at least one of them is true, the whole statement is going to be true. So this one is going to give you a true value. And you can practice with that, put different statements. You can have more than one expressions and combine them, and then check the result of all of those. So that is with or. With or, we include as much as we can. So if at least one statement is true, the entire thing becomes true. With and is the opposite of that. You need to have, you kind of excluding most of the stuff. So everything must be true for the entire thing to be true. So in this case, if at least one statement is false when it comes to and, the entire thing becomes false. Example of that, if you go back to the example of the pen colors. So let's say we have, start with red and blue. I say if you have a red and blue color, red and blue, then you can write. Of course, you can write because you have red and blue. But let's change this one to green. I say if you have red and blue, then you can write. Since one of them is green, the condition that you put there is not completely met, so you cannot write. Right? So if at least one statement is false, the entire thing becomes false. So let's take a look at examples. So if I have, let's start with true and true. So if both are true, good, you can do it. So pens are the colors that you wanted, you can write. If at least one is false, the entire thing becomes false. Example of that, just switching the statements is going to be false. If both are false, still is going to be false, okay? So when it comes to true, you're looking for something that is false. If it's false, the entire thing becomes false. When it comes to or, you're looking for something that is true. If at least one statement is true, the entire thing becomes true. Okay, so these are the operators that you need to play with, get comfortable, because we are going to use it in the future when we get to selection control especially, and creating different expressions for ourselves. Right, as I said, when it comes to operators, there's a certain order that you can apply these operators if you have multiple operators in one expression. So here's the order of them. As I said, you can find them in the PowerPoint slide as well. But the first one, if you have multiple one of these in one expression, exponentiation always goes first. You have negation after that, multiply, division, truncating division, modular are in the same order. Then we have addition and subtraction. All of the relational operators are in the same level. Then we have not and or. If you have, like for instance, in this example, you have multiply, division, truncating division, modular that are in the same level. If you have multiple one of those in one expression, or you have like two multiply in one expression, you're going to look at their associativity. And with all of the associativity, it goes from left to right. The only exception is with exponentiation. With exponentiation, it goes from right to left. So let's see an example of that. So if I have 2 multiplied by 5 multiplied by 4, what you do is you first multiply 2 by 5. It goes from left to right, and then the result of that is going to be multiplied by 4. If you have division, that makes more sense. So you first do this multiplication, and then you do the division, instead of doing the division first and then multiplying the result of that by 2. Okay, so when you have same level operators in one expression, you go, usually for most of them, you go from left to right. The only exception is if you have exponentiation. So with exponentiation, you go from right to left. So you first do 3 to the power of 2, which gives you 9, and then you do 2 to the power of 9. And that is going to give you the result 512. So just keep this in mind. So we have their level, so like how they go, there's a certain order with their priority. And then if you have same level operator in one expression, you always look at the associativity.